Good morning, everyone. What if I say there is a modern and better way of building SEO friendly websites for your organization? For the next few minutes, we are going to talk about how we can build modern websites and better websites which are more SEO friendly and which has faster page loads. So that is what we are going to see about. And myself, Mayappan, and I'm a senior architect in Ford Motor Company for the e-commerce space. In the past decade, the way of building websites were predominantly using content management system. As we all know, content management system is purely for managing the content, and it is an anti-pattern to build the website using a content management system. And recently, there is a shift in building the websites with modern tech stacks like Next.js and using micro-frontends. So this is the engineering blueprint that is put together to build the modern websites which can scale fast and which also uh, provides SEO friendliness to your entire website. So there is some problem statements that are widespread in building the website with a conventional way of building the websites. So first, it could be a diversified tech stack and it can be a fragmented platform. So what not? The websites can be built on React.js, Vue.js, content management systems. So it can be with a variety of tech stacks, and this would lead to inconsistency across your applications, which would also lead to the lack of reliability and observability. And with all these variety of tech stack, the key problem statement that one could face is also of slow page loads because all these frameworks are predominantly on client side rendering, which would impact your web vital scores like your LCPs, CLS. Then the organization have to rely on paid traffic. So, with all these problem statements in the agenda, we started putting this blueprint, and this would be addressed in three key areas. One, the product assets. Two, the platform engineering perspective, which is going to improve the developer experience. And third is on the SRE. So, the SRE are the ones who takes care of the application in the production with all their observability metrics, correct? So, now moving with the product, the entire application suite would be sliced as a micro frontend. Again, when I say micro frontend, most of you would think of module federation, but that's not what I'm going to talk about here. So the micro frontend would be based on build time composition, wherein the applications are server side rendered using Next.js, and all these applications would be aggregated in the runtime through a load balancer or through a front end CDNs. So, but during the build time, it will be composed together to form an application, and all these applications will be structured in monorepo. And Nx is the monorepo manager that has been used to organize all these Next.js application and to improve the reusability and sharing of components within monorepo. All these components are built as reusable components, perhaps not just component, but reusable web experiences. With all this, you would be able to improve your performance, and this performance would be shifted left, wherein from the beginning of the development you would focus more on your performance, which includes your web vitals, meaning the FCPs and LCPs and CLS. So obviously you want to hit a CLS of 0 and an FCP less than 1.5 and LCP less than 2.5. It doesn't make sense to take it at the end and then to measure it, right? So we have to shift left and we have to start observing it during our development phase. So when we do this, obviously you would definitely have an increased organic traffic growth rather than relying on the paid traffic. So your sites would be more friendly towards your SEOs. And keep in mind, when you do all this, you need to have a 360 degree of testing, starting from unit testing to functional testing, end-to-end automation testing, regression test suite, and even the visual regression test suite. So this is how the product is organized overall. And then now we have a product, but then we need to give a better developer experience, as well as you need to have a seamless CI/CD pipeline, and that's where the platform stack comes in. So the platform stack provides a customized dev experience tool for using the monorepo and building the apps within the monorepo. So overall, you need to have a monorepo governance hub, which would be responsible for all the toolings and the operations of the monorepo. And probably now this is an era where we live with AI and we use a lot of LLMs, right? So without that, it is meaningless. So probably you need to have LLMs wherever applicable. And in this blueprint, we used LLM for uh, PR reviews, code reviews, and then you would also have code sieve in your pipeline. With all this, we were able to get a 3x reduction in CI execution time, and then the entire suite of product are automated to be deployed in OpenShift cluster. So it could be any container platform, be it your GCP, Google Kubernetes engine, or it could be your AWS. So whatever it is, but in this blueprint, we have captured it as OpenShift cluster for more flexibility. So now you have everything, but what if you don't have a proper release management? With monorepo, with multiple applications called as micro-frontend, there could be left-right applications that will be moved to production, right? So we need to have a proper release management, and this is completely automated using Backstage portal.
Hello everyone, this is Balachandran Natarajan. I am the Platform Engineering Manager in Ford Motors e-commerce division. Thank you, May, for walking us through the engineering blueprint for micro-frontend monorepo architecture with server-side rendering, Next.js based Tailwind CSS front-end SEO-friendly websites. I will quickly walk through the SRE aspects of this blueprint and then deep dive into the platform part. So, with that said, the SRE, site reliability engineering, go through five critical design aspects. The first one being serverless SRE principles. We have given enough importance to adopt serverless ones. The best example is GCP's Cloud Run. Wherever possible, we put our backend service or front-end service with the cloud with the serverless functions to leverage its maximum engineering excellence. The next one is the unified observability and distributed end-to-end tracing with APM's availability and also cloud's capability with tools such as Dynatrace. We leverage unified observability and utilize Davis AI like features in the Dynatrace for distributed end-to-end tracing. The next one being the error budget based automatic risk mitigation. For every service, whether it is a backend or frontend, we measure availability and latency. And we have established benchmarks and thresholds based on the performance engineering results. So, with the Terraform IAC based error budget mapping, we constantly track the error budget for the 28 days rolling period, and every change request has been evaluated against the error budget, and based on its 99.9% uptime, the change request are given permission to get into the production. We also consciously maintain the uptime through this 99.9% uptime for the MTTR with the focus of less than 1 hour. We also continuously leverage AI ops for event correlation, anomaly detection, and causal analysis. With this, let me move on to the overall engineering blueprint for platform engineering. Though the picture resembles you, the most complex one, I'm going to help you simplify this into four different paths. The first one is the monorepo micro-frontend, Next.js Tailwind CSS BOM and app generator. And this is an intelligently automated backstage leveraged internal developer platform with the help of Tekton CI pipelines in KH driven workflow mechanism, leveraging NX as the application generator with the bomb push in the merge pipelines. With the help of AI, we assist the PR code reviews. CD pipelines have been done through Helm charts, and then we use code sieved pipelines with various quality and security gate checks while change requests are getting to the production. And we perform the integrated testing pipelines with Playwright, regression testing pipelines. We perform this during nightly build runs for all the open feature branches, and shared component management through monorepo governance establishment. As a overall, our release has been properly workflowed into various aspects of this. including observability and logging in Kubernetes, focusing enhancing performance and enabling proactive troubleshooting. Let's go and demystify each of these aspects, what I have given you as an overall summary. The first one being Monorepo Governance Hub. When we adopt Monorepo, the Governance Hub is extremely important. We have implemented to centralize management of multiple projects and components within a single repository. We have facilitated streamlined collaboration across teams by providing a unified view of code bases, dependencies, and configurations where conflicts are part of every day because every developer comes with a different point of view from the code bases and dependencies and packages configurations. The next one is the automated governance and compliance. Because of the domain where we operate, not all the other domains will be in the same plane. For example, health related aspects or a finance related aspects, the governance compliance comes into the very strong stringent way. So we have implemented automated governance policies to enforce coding standards. This reviews processes and security checks across all projects through various tools like FOSA for open source checks, checkmarks for static SAST ones, SonarQube for code quality, and just frameworks for test cases, and so on. So we utilize CI/CD pipelines to automate these checks and ensure compliance while we go through the navigation of builds. The next one is the AI based pull request code review process. We have done this through providing an intelligent insights and recommendations for the PR reviewer to speedify the review process. By understanding the entire concept of monorepo, these tools prioritize what are the important changes, bring the high impactful modifications, and suggest relevant documentation. For this specific thing, in NX, we are using NX affected notify and pipe it to AI driven code review tools powered by our own native LLM models and leverage the output of it to present to the reviewer what are the potential bugs, suggested improvements, and ensure adherence to the coding standards by adhering the context and patterns within the code base. The next one is the most interesting one, which is code sieve in the pipelines. As I mentioned, many of the analysis part are happening through our code sieve pipelines. As developers commit the code, it first enters into the code sieve, which is seamlessly integrated into the CI/CD pipeline. As a first step, it enters into the static analysis where our tools like codes, check marks gets through and then give a thumbs up in terms of the good to go. The next one is security filters. We have various SQL injections, cross-site scriptings are done by quality tools. And then we have dependency checkpoints where code dependencies and outdated libraries, typically known vulnerabilities in the third party components, are ensuring the code base remains secure and up to date. And then we have automated testing gates, and these runs a suite of automated tests, whether it can be unit test or regression test or end-to-end test, verify that the new code doesn't break existing functionality. The next comes performance analysis mesh. This layer assess the performance implication, provide the flagging of inefficient algorithms or a resource heavy functions like memory leaks, which can potentially degrade the system performance prior entering into the production. And finally, the compliance screening, which is the most pivotal one. If the code passes through this compliance filter, the industry regulations based on the domain where you operate, are like GDPR or HIPAA, can be safely passed through while the changes get into the production. The next one is 3x reduced CA execution time. We are leveraging NX executors for intelligent task scheduling. How we do this is through executing the tasks within the monorepo by taking The advantage of NX capabilities, such as how do we orchestrate the task? How do we understand that the dependency aware execution have been infused into the task list and then intelligently schedule, run only what is necessary based on the changes and significantly reduce thereby the build times. The CI integration pipelines done through continuous refactoring and optimization exercise. For example, in the past 12 months, we could have at least done 3 to 4 times of refactoring in terms of continuous improvement. It started with some 50 minutes to 5 minutes today through this enormous focus on engineering excellence. By parallelizing tasks, eliminating unnecessary steps, leveraging caching mechanisms, and avoid redundant work. Thereby, the execution times get saved. And through saving execution time, you not only save the developer's time and also save the processing dollars for those operations in Tekton pipelines. OpenShift Cloud Platform, OCP, SSR platform rendering. This we have chosen as a robust platform for deploying server side rendering applications. This offers enormous scalability, whether it is horizontal or vertical, in terms of replica parts, and resilience to handle fluctuation loads and ensure high availability. With features like auto scaling, load balancing, self healing, OpenShift can dynamically adjust resources to meet demand and maintain performance. In top of it, we also use Helm charts. Helm charts provide a powerful way in Kubernetes to manage applications in Kubernetes, include those in OpenShift by packaging all necessary resources and configurations for server side rendering applications. It simplifies development, upgrades, and rollbacks, making it easy to manage the application life cycles. With the Argo CD for GitOps, with a powerful combination of Helm, I think this will be helping us to maintain the MTTR less than 1 hour. Innovative release notes narration. Automated and precise versioning of release notes helps us to accomplish this through NX release change log. Conventional commits provide structured commit message format that includes information about the type of change, such as feature, fix, or breaking change, which NX can interpret and to calculate semantic versioning accurately. In this way, we captured this automatically and ensure precise versioning for the conventional commits. Thereby, this targeted release notes has been made much more simple for our engineering teams to generate focused release narratives that are relevant to specific stakeholders. And finally, our powerful release management engineering one. This has two broader aspects. One is the CI release pipeline, and second is the approvals, and the third is the overall CD deployment. The CI is the critical factor of it, and it contains various steps when people cut the release branch for a hotfix, for a minor change, or a major change. It has to pass through the gate checks, and if it is a hotfix, we bypassed it. If it is a minor or major change, it has to compulsorily pass through all security checks, and thereby, upon completion of this build process, release an RM request management ticket, and in the backstage, and developer will be informed via email, and upon filling that and then getting the necessary approvals based on the category, the versioning part and branching part have been standardized, and retagging and git release task gets executed, and semantic tag has been created for production, and git tag has been created for lower environments, and use Helm to Helm deploy into the production. We not only leave there, we also focus on dynamic property management for both lower and higher environments, respectively, with the necessitated pipeline integrated approvals for property management. With this, myself and May, we sincerely thank you for your valuable time today, for watching this session, and you can always reach me through the LinkedIn. In the barcode is already written in the screen, and I'm happy to connect with you for any further questions. Let's see that in our Q&A. Thank you.